All right, so next up we have Matt Nicholson. That was a bold move, showing that here, I gotta admit. One moment. Yep. All right, turn over to Matt.
Hey everybody, thanks for having me here and thank you for your time and attention. I know we're late in the afternoon here, so today I'll be discussing my SMT data challenge project that I have entitled Vacuums and Stone Hands, and this is an exploration of first baseman receiving here. So I want to start off with two different plays from the 2022 World Series here. The first is a ground ball to third base that is thrown across the diamond to an outstretched Rhys Hoskins here. And here he beats the runner, the throw beats the runner by just a half step here in this case. Now contrast that with the second play from the same World Series. It's a more sharply hit ball. The ball goes to the shortstop. The shortstop has plenty of time to make the throw, but the throw skips, and Hoskins is handcuffed by this play. So each of these plays are similar on paper, but they end in dramatically different ways. So in the first case, an out is recorded because Hoskins stretches. In the second, no out is recorded, and it gets worse from there. The shortstop is charged with an error, and a run scores in this case. So the main difference between these two plays here is the first baseman. And while this is, the contribution of the first baseman is completely ignored in a lot of the advanced statistics like UZR or outs above average. In the case where a successful stretch was made, Hoskins gets no credit for making this play. And in the case where Hoskins is handcuffed and isn't able to scoop the ball, Hoskins gets no blame outside of just reputation effects here. So, I'm not the first person to think about first baseman defense, and I won't be the last today either. But using tracking data allows us to come up with a more precise evaluation of defense broadly and first base specifically. So in this work, I aim to describe this phenomenon and make a methodological contribution. So I'm trying to demonstrate a viable framework for the evaluation of first base receiving here. So using player and position data from SMT together with game and event log data, I take an iterative approach to exploring this phenomenon. So notably on the data, we have no information on outs. So I first begin with a series of data quality checks and feature imputation and correction, notably within the player position and ball timestamps, and imputation to fill in outs here. So I then make use of descriptive statistics to explore this phenomenon and create and evaluate a framework for first baseman receiving from there. So give brief attention to several different aspects of my method here. So in the process of cleaning and exploring this data, I noticed that certain games, the player and the ball data was misaligned. So what does it mean to actually be misaligned here? This play is a 4-6-3 double play. And the thing to pay attention to here is when the shortstop makes the throw to first, the shortstop is nowhere near the second base at all. And this is a problem. So we need to actually correct this, and I did this in a systematic way. And now when we see this GIF, we see that the ball is hit to the second baseman, thrown to the shortstop, and then thrown to first. And in this corrected view here, the shortstop is actually on second base when he's making this throw to first here. So really importantly, without careful attention to this kind of phenomenon, this might be something that we are missing in the analysis of position data here. So beyond that, though, if we're aiming to describe first baseman receiving, and in particular what makes an out, we need to actually have outs in our data set. So we need to impute that in some way, and rather than taking a play level, we actually need to consider full sequences. So consider an example from this game here. And we start off with batter 1, and batter 1 has no one on base. And then when batter 2 comes up, batter 1 is now occupying first base. And then we see when batter 3 comes up, there is no longer anyone on base here. So the key point is that this alone, identifying what actually happened to batter 2, is not obvious until the half inning actually ends. So when we then see the next batter, and we see that we're now in the bottom half of the inning, we can then reevaluate this sequence with this knowledge and actually impute outs in a particular way. So reconsidering that sequence, knowing that there are only 3 batters coming up, we can start off and say there were no outs to start the inning, and batter 1 gets on base. And then, knowing that batter 3 is the last batter in this half inning, we can say with some degree of certainty that there must have been 2 outs on the play where batter 2 put the ball in play. And then from here, I did this for all games and all data, and then I filtered to only complete and trusted half innings and I departed kind of from there. So even though we have a bit more context and a little bit more confidence in our data at this point, that's not enough to describe first baseman receiving. So here's a still from a typical 4-3 putout, and we can compute features like the distance of the throw, the velocity of the throw, the angle of the throw to first base, where in space the ball was actually caught, how much the first baseman shortened the throw by stretching, if at all, as well as information on the batter in this case. So moving from there, we come to our key descriptive results, and this is an intuitive one here, which in general, and I'm kind of hand waving here a little bit, better throws are outs more often. And I'll describe that in a little bit more depth in just one second. So in this figure, what we're looking at here is an over-the-top view of first base, and we see that for the red hexagons, almost all of the receives that happened in that particular spot ended up as an out. And then for the blue hexagons, almost none of those receives actually ended up in an out. So in general, we see that the dark blue regions tend to be way off the back in this case. And have a bunch more descriptives that I didn't have time to talk about in this talk. But in general, we can take our descriptive results, like findings that outs tend to occur when throws are shorter, throws are more in line, throws don't bounce, and runners are further from the bag, and turn that into something predictive. In this case, I used a logistic regression to predict the probability of an out at the time a ball was thrown. So as with many analyses, especially defensive analyses, minimal assumptions constrain your decision space considerably. So to the point where they might not be representative of kind of the full data set here. So while I did compute like a receiving outs above expected, or rather above average in this case, these assumptions that I made kind of impeded the calibration of this model, and I have an appendix slide on this if folks are interested. And instead of reporting just like a full here is the best player, here is the worst player, I choose to characterize high and low probability events instead. So starting off, here we have a case where our model would predict that we are going to get an out, and we actually end up with an out. So in this case, it's a comebacker to the pitcher makes a flip to first, and we have an out. I would call this play routine. The second case we have is a case where our model would predict that we are not going to get an out at time of throw, and we actually don't. So in this case, it's a little bit more sharply hit, and the throw is well offline, and our runner is particularly fast in this case. So I would call this play a long shot. Maybe more interestingly here, we have the case where our model might predict that we should not have an out, but it actually ends in an out. This is what we're looking for when we're doing this. This is a play that we would not expect the first baseman to make, but the first baseman actually does. So the throw in this case is bounced and offline, and our first baseman scoops it. This is what I would call a great play for the first baseman. This is the kind of play that a first baseman should be getting credit for. And then finally, the last case we have here is a case where the model would predict that we should get an out, but we actually don't. And in this particular case, it's really hard to kind of interpret what's going on without additional context. So it could be that this is a blunder, or it could be this is a case where the first baseman is preventing something bad from getting much worse. So there's a lot of value in preventing kind of the worst thing from happening. And a good outcome on a terrible throw is the first baseman knocking the ball down. So here we have a still. This is Pete Alonso diving well off the bag to catch the ball and prevent the ball from trickling away here. So in this GIF here, we see something very similar. So the first baseman, or rather the pitcher, goes and fields the ball, throws to the first baseman. The throw pulls the first baseman well offline, and the first baseman does, in fact, actually catch this ball, preventing it from trickling away. So while this is super important, I leave treatment of this and other second-order effects as kind of future work in this case. So in this presentation, I hope to provide kind of a richer understanding of a ubiquitous but overlooked aspect of defense. And I've showed that the first baseman makes a very significant role in what makes an out at first base. So by describing what makes an out, have shown that this is worthy of further consideration, and we might extend this to scouting and valuation in particular ways. So thank you so much, and I appreciate your time here.
All right, great talk. We have time for one question. We got a question in the back there. Kwong is on his way.
Nice job, Matt. The bounce, you mentioned the bounce. Is that something that was described in the data, like the vertical height of the ball, or how did you think about modeling that effect?
Yeah. So the question was on the bounce and whether I modeled that directly from a Z position or event data. The answer is both. It was both a tag, and we also had a Z position data in this particular way. So did kind of an exploration looking at the effect of a bounce, and as a descriptive finding, found that bounce throws tend to be outs less often than not bounce throws. Thank you.
All right, let's thank Matt.